Hey there, this is Wasabi. There are several guides out there on how to build the main electrical circuit in Rust that best fits your base. I want to show you my approach to this. This is an expert circuit. Make sure to practice it on a build server first. Basically, there's always a power source connected to some electrical devices. To account for fluctuations in incoming power, you usually place a battery in between. So, in case the wind is low or the sun is out, you still have backup power. The problem with this simple method is that it wastes a lot of power once the system scales up. The battery only charges with 80% of what comes in. This means that in order to provide 100 power from your battery, it has to be charged with 127 power on average to remain full at all times. Now, the bigger the base gets, the more power you need, and 27 power per battery is a lot of waste. Imagine having 3 batteries, each wasting 27 power. That's 8 turrets or 3 sets of 9 electric furnace chambers. Of course, there is the all-time famous Nih-Core out there. I won't go into too much detail here, but it essentially powers everything directly from the power sources and uses what's left to charge the battery. When the incoming power fluctuates, the battery kicks in and takes over until the main power comes back online. While being used, the batteries charge at the same time with what's left from the power sources, extending the backup time. So far, so good. But the Nih-Core has its downsides. It usually works best with only one battery, and if the circuit is destroyed, the power goes down, battery or no battery. It fits very well into small bases that only need 1 or maybe 2 batteries, meaning 100 to 200 power. Once your base scales up, you need something different: redundancy, scalability, and reliability. If the enemy destroys your main circuit, everything should still work. And as a cherry on top, it would be nice to have a secure central switch that turns everything off in case little Roger comes late to the game and needs turret off. So let me show you how I do it. My circuit consists of 3 parts: the main circuit that powers everything and charges the batteries, a timed central smart switch that turns everything off and on automatically once the timer is up, and then there are the individual battery compartments that hold the electrical components for everything that needs power, like turrets. These are spread across the base in strategic, hidden spots that usually don't get destroyed in a raid. Every battery compartment is working on its own once the main circuit is being destroyed, so no need to hide the main power distribution. The circuit is scalable up to 12 battery compartments, meaning 1,200 power in one circuit. We're talking big bases here. Why the limit of 12 batteries? Because of the electrical depth limit in Rust of 16 components between the power source and batteries. Let me show you how I build it. First, I put all these components on the wall. This is always the same, and it can be built early on. From the main circuit, you can extend your setup step by step, starting with a single battery compartment somewhere in your base. It is essentially a modified Nih-Core, and the principle is the same. Charge the batteries with what's left from main power. The batteries stay unused and fully charged until needed. But since the main circuit is separated, it doesn't matter where it is located. Let me walk you through the power path from the power sources. Main power, purple, takes its path up to the second memory cell and then into the first splitter. If we start with just one large battery, I set this branch to 102 power. 2 power is for another purpose. More on that later. This purple cable is our main power, meaning once we are above the power threshold, which we set to 102 a moment ago, this will power everything in the base. What happens to the excess power? This comes from the threshold branch. The power out goes into another branch, and the power out of this one takes its path into another splitter. Now, we need to connect the magic stuff that will swap power when input power fluctuates below the setup threshold and back again. We use the second memory cell to switch outputs when input power drops below the threshold and send everything to battery charging. This is tricky because Rust is kind of broken, but I found a way to do it reliably. How it works is that once this branch here has power, the memory cell goes to main power. If the power is low, it switches to battery power and puts everything there is into charging. This is one of two complicated things, but once you wrap your head around this, it's pretty much rinse and repeat every wipe. But Wasabi, you could do that with just a branch or a splitter right here, you say. And this is where Rust is broken. This does not work at this point, at least not at all times, so I had to come up with a secure way of doing it. The problem here is that the fluctuation of input power is sometimes so small or large that the game doesn't recognize the set or reset on the memory cell. Just trust me on this one here. So let's quickly add some wires from the alternative outputs here to the battery charge circuit, and we're pretty much done. The rest of this will connect later. It will be the central kill switch. Let's have a look at the battery compartment for now and how to connect it to the main circuit. This is very easy and will look the same all over the base. In the battery compartment, we have a large battery, a branch, a blocker, and 2 switches. Because I want to connect 10 turrets to this battery, I also add 9 branches on top. Again, this is the same on all batteries. Main power, which is the purple splitter, takes its path through the branch into the left input on this OR switch. Battery power, which is the green splitter, connects to the battery, and that one to a blocker, then to the right side OR switch. This is important because we set the branch to 100 power. This means the OR switch gets 100 power from the main circuit and 100 power from the battery. So how does it know which one to let through? It is always either the largest amount or the left one. So because we want to use main power first, we connect it to the left one. That way our battery stays in backup mode. And that's it. That's the circuit. To scale up, connect more battery compartments as you go, and adjust the main circuit's branch to the total power plus 2. So with 3 batteries, this would be 302 power. With 12 batteries, it will be 1202. Now, let's add the central kill switch. Add a small or medium battery charged via the dead-end 2 power branch from earlier. That's the 2 from our threshold. This battery powers a branch over here. This branch out powers a smart switch, which then powers another branch. The power out of the first branch goes into a timer, and that timer goes into a branch, and that branch out into the splitter, and the splitter into the first memory cell. The power out of the branch up here goes into our third splitter. The branch out of the branch behind the switch goes into the timer trigger input, and the power out of the branch behind the smart switch will turn the switch off once we hit it. This second branch is set to 1. The blue wire represents the kill switch circuit. That was the second complicated part. Why am I doing this? Well, the switch is actually not a switch, but a trigger. It triggers the shutdown of all turrets in the base for a specific amount of time. To avoid the need of turning the switch off manually in the Rust Plus app or by hand to be able to use it again. You could do it, of course, differently and just leave out the timer and the 2 branches and connect the battery to the switch, and that one to the branch. Then you have it manual. How does it work? Once I hit the kill switch, or trigger, a signal goes into the memory cell that sends everything into battery charging, the green wire. At the same time, we send power into the blue splitter, which blocks the power on all the battery compartments. To make that work, we have to connect the blue splitter to the battery compartment to the first OR switch. I usually set the timer to 120 seconds, but for demonstration purposes, this is the default 10 seconds. Once I hit the switch, all the turrets turn off, and after the timer is up, everything turns on again. Now it's just a matter of how much power you can provide on the input side and how many batteries you want to have in your base. Always have an eye on the average input power. It has to be higher than your threshold. This circuit is battle-proven and I used it for years now. If I reach the maximum of 12 batteries in a base, I just start another circuit. And a little quick tip in the end. When adding industrial components that should not be affected by the kill switch, add a separate branch before the main circuit. I hope this approach is useful to you in any way. Let me know in the comments what you think. Sending good energy. Bye.